Hello Internet, in this video we are going to be combining two random tools that one I've never used and one that I've used quite often. So we're going to be using Morph 3D, which creates this character here. It's a Unity plugin and I think they support a few other places as well. There's a free version and a paid version. This is the paid version, but you can use the free version and it should work for this. We're also using Microsoft's facial recognition AI software. So this is an Azure service. You may have seen some of the demos during like build or something like that. What it does is it takes a picture of your face, this face right here, and then it gives you, let me get to it, a giant JSON blob. It's actually probably easier to see here. I copied all of the JSON into just a file. There we go, so we could see it. So it tracks 27 points on your body, and then it gives you all of their positions, gives you your gender, your age. This one is being very nice to me. The other two, I took 3, weren't so nice. This one says I'm 21. The other ones are closer to 30. Not sure I appreciate that, but that's there. It also gives you the rotation or tilt of your head, some facial hair, glasses. Realizes I'm reading I have glasses on. And then it also gives you some emotions. So what we're going to attempt to do is tie some of this into Morph 3D so we can take a picture. I kind of want to integrate this with like a webcam or something and have it do, like, you take a picture, it builds your character based on you. I think that'd be really cool. That's where I want to take this. So Morph 3D lets you do a bunch of morphs on your model. And I think we can do something similar to this. So this is the unmorphed model, but there are a lot. You'll get less if you use the free version. That's what you get for the paid version. But each of these are various morphs for different things. So like we can make a person heavier or not. And it all sort of conforms. So you can all of these can be adjusted dynamically. So we can kind of change all of them. So what we're going to do is bind some of these to the output from that API. So one note, I am not actually calling the API here. Beforehand, I wrote this face database thing, which all it does is it takes this JSON and parses it into this structure so we can actually read it. So I'll show you what actually happens. So we have this image here, which is tied down here. And I just have 3 images that I had scanned beforehand just so we didn't need to deal with those. And at least when I started this, my API key hadn't come in yet. So I couldn't actually call the API. I could just use their samples, but it works. So we can switch through them, but just by changing this, and it automatically will update all of these points. So all we need to do is just watch this parsed field and plug it into our face. And theoretically, we can actually change everything. Don't know how well it's going to actually work. I think we'll probably start with just the head position because that's actually super easy to do. This is our clothed Morph 3D object. It's just the Morph 3D male. There's also a female variant if you're interested in that. All we need to do, I think, is modify this. So just take the head bone and turn it a bunch. And we already have the yaw, pitch, and roll. So we can just do that. I might need to remember my yaw, pitch, and roll and actually figure out what those mean, because I'm pretty sure I forgot them. But we're going to pretend like it works. So let's just jump into it. So first off, I'm going to tie to our face database. And we're going to tie to what? Let's tie to our head bone. So the head, just so we have that for reference, so we can actually just start transforming that. But we're also going to need to tie to that morph engine so we can start modifying some of those values. That gets a little bit more complicated, but it's sort of how we have to do it. So I'm not entirely sure the best way to do this. So we'll just call this the database. And then we need a transform that will represent the head. And then in our update, we can just do this every frame just because we can. It's probably not efficient. Well, it isn't efficient, but we can do it because why not? So we're going to do a transform. Yeah. And actually, let's make sure. So if the database.parsed is not null, so if it's actually done its thing and parsed out that JSON string, if it hasn't, we're kind of stuck. This is just kind of to protect us from that. We're going to do set the head transform dot local rotation. So this is just going to set the rotation of that bone equal to a quaternion dot Euler angles. So this is just going to take, I believe, degrees. Yep, degrees from our database dot parsed. And then we just need to go into the face attributes. This is just strictly coming straight out of the JSON. So all of these things up here are just the JSON view models that I'm using to actually serialize this whole thing. So there's nothing fancy here. It's just a serializable attribute on some class, and then just some fields, some public fields. And then the parsing actually happens here, which is just the single line using Unity's built-in JSON utility. One of the issues is this face API actually can detect multiple faces in it, and it returns an array at the top level, which this can't actually handle. I don't know why, but it can't. We've run into this in the past because I've done a few videos where we've had to parse JSON. For whatever reason, it can't handle an array, a top-level array. So I actually took out that, so it actually works because it's just my face, so we don't need to worry about it anyway. But if you start using the API, you will need to deal with that somehow. I don't know how, so good luck. What are we doing? We're taking the head position. And so pitch is going to be up and down. Roll is going to be along the z-axis. So pitch will be x. Yaw will be y. Yaw is going to be, is that? Yeah. Pitch is this way. Yaw is this way. Pitch is up and down. And then roll is obviously side to side. So we're going to do pitch, yaw, roll. I could probably store this somewhere and not go through all of these every time. But screw it. We're going to do it anyway. So database parsed. Let's take the face attributes, and then we'll use the head position with a roll. So this is going to look really weird because I'm not interpolating between this at all. But it should at least get us a face position. So I would expect it to rotate just slightly. Actually, no, I won't, because I didn't actually attach it to anything. That's kind of required. There we go. So we'll attach our head and our face database there. And then we can actually pull this in. And we get, it looks like it's the opposite direction. But you kind of get the idea. So we can fix this. Coordinate system is backwards, because instead of looking down, we're looking up, and we're looking in the wrong direction. So I'm just going to reverse those. And the goal here, just to be clear, is to kind of replicate the picture. So the camera's a little bit offset, which is probably why this is looking a little bit too off. But if I fix that, it's close. It's fairly close. I'd say that's doing a pretty good job. So I don't know what this is actually going to end up looking like. I've just got a bunch of random pictures of my terrible face, but whatever. So the next thing we need to do is actually start adding some of the emotions. So it gives us, I think, like 8 different things we can use. And this is actually coming from a different API. If I remember correctly, there's the face API and then there's the emotion API. This is coming from the emotion API, but they just kind of merge the responses, which means we get it for free. So we need to do happiness, neutral, which can just be nothing. I think that'll work for us. Sadness, surprise, fear, disgust, contempt, and anger. And so we just need to find something that actually works for those. So we're going to be jumping into our head groups. And I think these are named funky things. So let's actually start looking at our face. That looks hilarious. Yeah. So what? So I should point out at this point, I don't really know what I'm doing with this tool. I've had it for a while and I've used it like Red. All of the characters from Red are using this system. I actually did have random generation in there too. So you'll see some of the characters in that game are different shapes. But it's been a while since Red. I think we did that project in October. So yeah, it's been at least 4 or 5 months. So I need to figure out what I am doing. There are all of these expressions here. And each of the, so they do have names. Awesome. So I'm going to shrink or make this really big so we can see this. They all have names, and these are, I would assume, the names. I could be wrong there. But we actually have like disgust. So I can do, that's full on disgust. But the cool thing is we can merge all of these. So I can literally just take the value I'm getting from Microsoft's API and plug it directly into this. And so we can kind of get this merge of different emotions on the face, just like that. So that's what I'm going to start doing. We're going to need to map each of those though. So I think the way to do that is probably just with string names. So I'm going to expose them as just a string. And we're going to need each of those. So I'm just going to copy this, expose them like that, and make them strings. And then we'll tie a name onto the end of them. Probably like anger body. That's probably a bad name, but we'll go with it. Why not? So this is just going to be the name that we're actually mapping to. So if the name exists, we want to do something. So in here, let's just go for it. So we've got our database. Actually, let's grab our morph something. I don't actually know what it's called. It's called like a morph 3D. Why are there 2 different namespaces? That is weird. I think it's the character manager. Could be wrong. We'll know pretty quickly. So we're going to just call it the manager. And we need to set that up. So manager dot set. Yeah, set blend shape value. So you need the name, which we're going to be setting. So we're going to do like anger body. And we're going to set that equal to our database parsed face attributes emotion dot anger. So we can just start here, I think. Oh no, let's just do them all. Why not, right? So ooh, that didn't work. Okay, I'm gonna have to type these out. So sorry for the delay, but we're going to get these working, and then theoretically, I'm actually going to skip neutral because that's just going to be nothing. So it's just going to be the percent of your emotion that is just your blank face. So just that. I don't know if that's actually going to look correct, because so part of the issue is some of these may map to look a little bit different than Microsoft is mapping them, because Microsoft is using a neural network and these people are using a bunch of weighted bones. So I don't actually know how similar this is going to turn out. I just think this is going to be super cool, where you can actually, like, theoretically, you can look at somebody's like reaction to something and record that, and then rig all of this stuff up And all of this can happen dynamically. We can animate each of these blend shapes. So we could theoretically actually like animate somebody's doing some sort of emotion, like some reaction to something. We obviously probably couldn't record it in too much detail because you're not going to be able to submit like every frame to this framework and actually just animate it that way. That won't work, but you can take like a snapshot, capture it, get the value out of it, and then, yeah, animate it to look like that. So theoretically, this will work as soon as we get all of these working. I believe there's some way you have to actually apply this. I've gotten in trouble in the past for not applying. So sync morphs to something. I'm going to pretend like we don't need it. That's a mistake. But we're going to do it, and then we'll get there when we get there. So all of that's good. Let's jump back here. I'm going to do a quick, ooh, that wasn't right. Okay, so it just closed it for whatever reason. I'm going to actually lock this. So you can lock things with this little lock button up here in Unity. It means that this won't change, so I can actually select something totally different and it doesn't change. Which may have just totally screwed things. Can't do that yet. Got a little bit ahead of myself. I need 2 inspectors. How can I get 2 inspectors? Because that's going to make this easier. So we're going to figure that out. Might be more work than it's worth, but I'm sure it's worth it. So let's try to open another one. Nope. Okay. I tried. Oh wait, hold on. Got it. Awesome. So we now have 2 inspectors. I'm going to lock this one, and then I'm going to select our face over here. That's wrong. I'm going to select our dynamic face over here, and we just need to copy these. So these names need to come over here. And I believe they'll map just like that. I could be very wrong, but I'm just going to pull them over, see if it works, and then if it doesn't, we'll figure it out. That's pretty much everything I do. So happy, neutral, I don't care about because we're not actually using that. Sad, it's kind of nice that these all map. Surprise does not have one. Oh wait, yes it does. Awesome. So they all mapped, which is great. I don't know about the free version. I don't know if all of these will be in the free version. I know it's limited. I think there's only 40 morph shapes or something. This one has almost 200. So you won't get as much out of it, but you can still play around with it. And I'm sure there's something you can do with that. So yeah. Where were we? We need to assign this to our, character manager. Cool. So it's all done. Does it actually work? I suppose that's the actual question we need to answer, isn't it? Probably not would be my answer. Because it doesn't look like it got applied. We can check. So the cool thing is this will actually change as I cycle through these. Yeah, so the face isn't changing. It's rotating though. So it's matching the rotation. It's just not matching this. So I should have got some with more emotion in them, but unfortunately a lot of these are neutral. So let's see if I can crank this up. So if I do like happiness at 1, neutral down to 0. Yeah, no, I don't think it's not updating. So let's try those sync functions. If this doesn't work, I'm going to have to go and actually like read documentation, which always works well. sync morphs. That's not what I want. Is it? I don't think it is. I should read some documentation on this. Sync all blend shapes. Okay, we're gonna try this. I'm pretty sure this will work. I don't think this is optimal because this is gonna send all of the data, which you probably don't wanna do, but we're going to try it, see what happens, and then get confused when it doesn't work. Aww. It was supposed to be so easy. Okay. So clearly, we still have some work to do. Expression. Wait, hold on. Oh. It's using floating point values. We need to multiply these by 100. Because so morph goes between 0 and 100, and the API is going between 0 and 1. I'm pretty sure I said that they mapped up. I'm pretty sure I was wrong. So this should actually work now. So I should be able to do this. Open up our morph groups, our head, and our expression. We'll see they're mapped. Right, that's not going to change anything. Sure, 10. But if I do like somebody that's super sad, we get that. But yeah, so it is actually working. Apparently I wasn't very happy in that picture. I look like I'm deep in thought. Nice, nice. Okay, so it is working. Cool. So we can actually sync up. Let me actually rotate our camera, and I'll move it just a little bit. There. So now our camera is straight at our face. So these should now match more closely. Obviously, it's still learning, so it may not be perfect. I would be very surprised, actually, if it was perfect. But you get the idea. We've got me looking really... I don't even know what that is. Neutral. Somewhat happy. And then this, whatever that is. So yeah, what we now have a way to sync APIs, I guess. Not really APIs. We're syncing an artificial neural network result into our game and then actually creating a face from that. So we're getting a lot more data than I'm using here. A lot of stuff that I haven't gotten to using yet. So this actually calculates like the shape of your face as well. Obviously it's a 2D image, but based on that 2D plane, it actually puts a bunch of points, so it can actually identify where your pupils are, where the tip of your nose is, and things like that. So in the future, we can actually take these landmarks and actually start like stretching it out. So if you have like high cheekbones, it can actually detect that. And we can actually plug that into this. So you don't just get the default face, you actually get one that looks more like you. I don't think we get like hair color, for example, but we can also do things like age. So you can actually like age your model if you need to, which we can actually tie into the age as well. So yeah, there's a lot of stuff to do with this. I think it's going to be a really fun project. So if there's anything you guys want to see, any other ideas or data points you have, if there's some other data set out there or some other way to get this kind of data, let me see it, because then we can try to plug it in and see how do they compare, or can we combine them and get even better results. Or if you have an idea for how to actually apply this, go for it or let me know. Because I don't think we're going to be building a full RPG and actually like having a character creator that automatically builds it from a webcam image. But we might get to like the webcam bit and then kind of stop. Building a full RPG is years of work that I don't really have So we're not going to do that, but we're going to do this. So yeah. Yeah. If there's anything else you guys want to see, leave a comment. That's how I learn. That's how I get better. So yeah. Until next time, see you, internet.